Hi, I'm Kathy Levinger. In this lesson we're going to look at square roots. Let's start with some examples and terminology. What we want to do here is evaluate some square roots. If a root is not a real number, we're going to explain why. And the first square root we want to evaluate is the square root of 100. This symbol is called a radical sign. In particular, for this example, it's a square root symbol. The square root of 100 is the number 10 because 10 squared is 100. The square root of 100 is 10 for this reason. The next root we want to evaluate is the square root of negative 64. This is an example of a square root that is not a real number. The reason it's not a real number is we're trying to take a square root of a negative. In the third example, we want to evaluate negative the square root of 36. Well, the negative is outside the square root sign, and so it gets attached to the number that is the square root of 36, which is 6. So when we evaluate negative the square root of 36, we get negative 6. Well, let's continue in this discussion and talk about some different sets of numbers for a moment. Here's a list of numbers. From our list, we want to identify those that are rational numbers, those that are irrational numbers, and here we are again with this idea of non-real numbers. Let's start by listing the rational numbers, or pulling the rational numbers from our list. Rational numbers are ratios of integers, so the first rational, or the first number in our list is a rational number. The next number in our list is the square root of 12. That cannot be written as a ratio of integers, so it's not rational. The next number is negative 3. That can be thought of as negative 3 over 1, which would make it a ratio of integers, so it is rational. The next number is 4 over 7, a ratio of integers. The next number is the square root of negative 2. Now that's not possible to, or it's not possible to write that number as a ratio of integers, so it's not rational. Pi is also not rational. The number 6.22 is rational. It's what we call a terminating decimal. It can be written as 6 and 22/100ths, which is a ratio, or could be changed to a ratio of integers. So these are the rational numbers in our list. Let's pull from the remaining numbers those that are irrational. Irrational numbers are those that are real, however cannot be written as a ratio of integers. Well, there's two irrational numbers in our list. One of them's the square root of 12. There is no set of integers that I can put into a fraction for the square root of 12. And the number pi, which is a non-terminating, non-ending, and non-repeating decimal, as well as the square root of 12. And so the last number in our list is the one that is non-real, and that's the square root of negative 2. Anytime we try to find a square root of a negative number, the end result is not real. Well, let's go back to square roots and talk about simplifying square roots, and we're going to check our simplifications with the calculator. The first square root we want to simplify is the square root of 48. There is no exact square root of 48, so what we're looking for is a way to factor 48 so that one of the factors might be a perfect square. Well, I know that 48 is 16 times 3, and I know that 16 is a perfect square, so I'm going to start by factoring 48 as 16 times 3. Now, since 16 and 3 are both real, I can break this into the square root of 16 times the square root of 3. And I know that the square root of 16 is 4. There is no exact square root of 3, so I leave the square root of 3 as it is. And 4 square roots of 3 is the simplification of the square root of 48. Let's simplify the next two before we grab a calculator to check. We want to simplify in a similar fashion the square root of 300. So I'm looking for a perfect square factor of 300. 300 is 100 times 3, and 100 is a perfect square. So here's a convenient way to factor 300. Now I break this into the square root of 100 times the square root of 3. The square root of 100 is 10. There is no exact square root of 3, so I leave that in the form square root 3. The square root of 300 simplifies to 10 square roots of 3. The third example we want to work on here is 5 square roots of 28. The 5 we'll leave alone for a moment, and we'll consider factoring 28 into something times a perfect square. Well, there's my 5. I'm going to write 28 factored as 4 times 7 because 4 is a perfect square, and then break this radical into the square root of 4 times the square root of 7. Now the square root of 4 is 2. That 2 will multiply by the 5 that's already outside the radical to give me 10 square roots of 7. And there is no exact square root of 7, so we've written that square root of 7. So 5 square roots of 28 is 10 square roots of 7. Now I want to check all 3 of these on a calculator. What I'm going to do to check, let me check the first one, is enter on my calculator the square root of 48 and simplify. The square root symbol is down the left column, so I choose the square root, then enter the number 48, close parentheses, and enter to get a decimal. The decimal is 6.9282 and so forth. As a second operation on my calculator, I'm going to enter what I got when I simplified the square root of 48. I'm going to enter 4 square roots of 3 by typing 4, choose the square root symbol, then a 3, close parentheses, and enter. Now I'll zoom in on that screen and I'll show you what we see. You can see that the square root of 48 is the decimal 6.928, etc., and 4 square roots of 3 is exactly the same decimal, and that checks the simplification that I found. Well, let's check the other two in a similar way, the other two examples that we worked. We will enter the square root of 300, get a decimal, 17.32 and so forth, and I'll now enter 10 square roots of 3 and get a decimal, and I see that it's exactly the same, 17.3205 and so forth. Let's clear that and check our third. We have 5 square roots of 28, and that's about 26.4575 and so forth. Now 10 square roots of 7, and that's the same decimal. So that checks also. Let's look at a couple other simplification problems involving square roots. Again, we want to simplify and check our simplifications with a calculator. So the implied directions here are simplify by hand. The first example is the square root of 4 squared minus 4 times negative 10 times 2. Inside the radical, we begin using order of operations and simplifying the exponent. 4 squared is 16, minus 4 times negative 10 times 2. Now this is subtraction. I need to do all the multiplication before I can subtract. The multiplication is 4 times negative 10, which is negative 40, times 2, which is negative 80. So this becomes the square root of 16 minus negative 80, the number negative 80. That is 16 plus 80, or the square root of 96. Now I need to simplify that using the procedure that we worked with a few minutes ago. I know that 96, or I think that 96 is divisible by 16. It is. It's 16 times 6. Break this into the square root of 16 times the square root of 6. The square root of 16 is 4. And so 4 square roots of 6 is the simplified version of what we started with. We'll check that in a minute. But let's move on to the next problem we want to work here. This reads the square root of the number negative 5 squared minus 4 times 2 times 3. Well, let's start with the exponent in the radical. Negative 5 squared means negative 5 times negative 5, which is 25. I have that minus 4 times 2 times 3. And now I'm ready to multiply before I subtract. I have 25 minus 4 times 2 is 8, times 3 is 24. And so this, once the subtraction is performed, is the square root of 1, which is 1. Well, let's check both of these. Starting with the first one, I'm going to enter exactly what I see here on my calculator. So I'm going to start with the square root symbol, and the calculator automatically puts an open parentheses. Next to that, I'll put 4 squared minus 4 times negative 10 times 2, but I need to close for the end of the information inside the radical, and then I'll push enter. I get a decimal, 9.79 and so forth. Let's enter also 4 square roots of 6 and see if that's the same decimal, and it is, and I'll zoom in and let you take a look at what I entered on my calculator. I have the square root of 4 squared minus 4 times negative 10 times 2 with a closed parentheses for the radical gives me this decimal, and then 4 square roots of 6 gives me the same decimal. So our first problem checks. The second one's going to be a little simpler to check. All I have to do is enter the problem and see if the end result is 1. So let's do that. We have the square root of parentheses, an additional parentheses, negative 5, close those, squared, minus 4 times 2 times 3, and close one final time, and we get the number 1, which verifies that particular problem. Let's move on and talk about multiplying radicals. Here's some problems we want to try. We want to multiply each pair of radicals and simplify our result. Multiplying the square root of 12 times the square root of 6, what I do is multiply, as long as these are real, the radicands, which are the things inside the radicals, and put that product inside a single square root. So I want to find the square root of 12 times 6. 12 times 6 is 72, so my problem is to simplify the square root of 72. Well, I'm looking for a perfect square factor of 72. I know that 72 is 36 times 2, and so I'm going to break this into the square root of 36 times the square root of 2. Simplify the square root of 36 to get 6, and next to it write the square root of 2, and that's the simplified version of this product. Well, our next problem reads the square root of 20 times 3 square roots of 15. I could multiply as I did in the previous problem, except that I see the square root of 20 simplifies a little bit first. Let's do the simplification of the square root of 20 before we multiply it by 3 square roots of 15. I'll consider the square root of 20 to be the square root of 4 times 5, and take the square root of the 4, which is 2, and now my multiplication problem reads 2 square roots of 5 times 3 square roots of 15. Well, I can multiply together the two numbers inside the radicals and the two numbers outside the radicals to get 2 times 3, which is 6, that's the product of the numbers outside, times the square root of 5 times 15. I need to multiply 5 times 15, and if I do so, I'll get 75. And now my problem is to simplify 6 square roots of 75. 75 factors into 25 times 3, and so my problem now is 6 square roots of 25 times the square root of 3. The square root of 25 is 5. Take that 5 times the 6, which will give you 30 square roots of 3 as a simplified answer to this multiplication problem. Let's try one more. This problem reads 2 square roots of 7 times 3 square roots of 14. Now neither radical simplifies as they are, so we're ready to go ahead and multiply. And as with the previous problem, we'll multiply the 2 times 3, which are on the outside of the radical, and inside the radical multiply 7 times 14. 7 times 14 is the number 98. And now my problem is to simplify 6 square roots of 98. 98 factors into 49 times 2, and so I can consider my problem to be 6 square roots of 49 times the square root of 2. The square root of 49 is 7. That 7 times the 6 gives me 42 square roots of 2. In this lesson we looked at radicals. Be sure to work lots of problems from your textbook to practice.